Okay, so this monkey problem is a classic problem in physics, and there's lots of different ways to do this. But first I'd start with a picture. And to answer one of your questions, this is really a kinematics problem. So I know we're doing the forces unit right now, but this is a good two-dimensional kinematics problem just to make sure we know what we're doing. The hard part about this is how do you solve the problem? So I just drew a little sketch here. The zookeeper is laying here 100 meters away from the monkey, and the monkey is 15 meters up off the ground. So one of the first things I would do is calculate this angle that the zookeeper is probably going to point his or her gun at. And let's assume that they're going to point it straight at the monkey who's sitting up here at the top of the tree. So I start off with tangent theta equals opposite over the hypotenuse. Do my tan inverse, and I get theta equals 8.53 degrees. So now that I know what angle he or she may point the banana shooter at, I'm going to go ahead and split this vector, this 30 meters per second velocity vector, into x components and y components. So I'm going to find that Vx is equal to 30 times the cosine of 8.53, which is 29.7 meters per second. In the y direction, it will be rising at 30 times the sine of 8.53 degrees. So 4.45 meters per second. Okay. So a couple things here. And in this video, I'll go ahead and work through this problem, but I'd encourage you at any point you think you have an idea to stop the video and try this yourself. It's always easier to see your teacher solve it because they've solved the problem before. I guess my first question is, what path is this going to be traveling when it gets to the point where the monkey is? If you think about it, of course my picture's not drawn to scale, but you know, the dart could rise and fall, so be on its downward path when it's traveled 100 meters. It could be still rising when it goes past, and of course it could hit right at the top of the parabola when it goes past. So I guess my first question I like to think about is the dart still rising? After it's traveled a horizontal distance of 100 meters. Right? And so that would be semi-easy to check. What we could do is figure out how far does it take to get, or how long does it take to get to the top of its parabola. If there's no monkey in the way, and it was just left to follow its perfect parabola, we know that V initial would be 4.45 in the y direction. We know at the top of that it would rest momentarily. It would not be moving up or down. Of course, it would still be moving over at a constant 29.7 meters per second the whole time. On the way up, it would be slowing down due to gravity. So let's just see how long that would take. So I can use V equals V naught plus AT, which would be 0 equals 4.45 plus a minus 9.8 times t. So do a little algebra here, and you end up with 4.45 divided by 9.8, which is 0.45 4 seconds. Now, in the x direction, remember, little kinematics review, is we ignore air resistance. Therefore, there's nothing that can accelerate the banana after it's been shot in the x direction. So we're going to use V equals d over t. And we know that the x is 100 meters. Actually, let me think here. Let's do Vx times t and solve for the x, and then we can compare that to the 100 meters. So I'm going to take 29.7. I'm going to multiply by 0.454. And I get that it's traveled a distance of 13.48 meters. I feel like I've done something wrong. Oh, well, I guess it's a pretty, okay. So it's traveled 13.58 meters, and it needs to go 100 meters. I'm getting nervous about this. We might have to use a greater angle than 8.53 degrees. Okay, so one of the first questions they say is, what angle are you going to point at? Well, at 8.53 degrees, it's only going to travel 13 meters to the top of the parabola and another 13 meters. So if we don't increase our angle, the shot's going to be pretty unimpressive and have something like this. All right, so that means we're going to be back to the drawing board in that we need to think about increasing our angle that we shoot the banana at. Okay, so I'm tempted to get my eraser. Oops, that's not the eraser. I'm tempted to get the eraser. I wonder if there's like my smartboard. Nope, it's not. Okay. As opposed to sitting here and erasing this whole thing for you guys, I want you to think about this. And I might leave this with you and then have you come back to me if you have questions. But if you're trying to get a projectile to go as far over as it possibly can go, then that 45-degree angle is awfully tempting. Because if you shoot it at an angle greater than 45, it'll go pretty high up in the air, but it won't go very far over. And if you shoot it closer to theta is 0 degrees, it has that potential to go farther over, except it's not in the air very long. Gravity is just pulling it straight down. So we probably are going to need to think about what angle we're shooting at. And I would say pick an angle above 45 degrees or right at 45 degrees might be a good way to start this problem. And then go back to my original question, which would be, at that angle, when the dart has traveled 100 meters, is it still rising or falling? Because now I feel like what we should think about is if we change our angle, can we arrange for it to get here at the top of its trajectory and then go from there? All right, so that's my suggestion. Try it and then let me know how things go. Okay. Whoops, I don't know how I did that. Okay, so I redrew my picture with this 45-degree angle, and let's go ahead and right away split our 30 meters per second into components. Oops, that's a sign. Okay, when we take 30 times the cosine of 45, we get 21.21 degrees. So it'll be moving over at 21.21 meters per second, and it will be going up initially at 21.21 meters per second. So again, let's look at how long it takes to travel that, or to get to the top of its parabola. So choose the equation without d in it, which is v equals v naught plus at. So we get 0 equals 21.21 plus a negative 9.8 times t. So I'm going to have 21.21 divided by 9.8. So now it has 2.16 seconds to rise. Okay. So I come over here and I say, well, how far will it have traveled in 2.16 seconds? Well, if it's traveling at 2.16 seconds, then I could take 21.21 and multiply by 2.16, and it will have traveled 45.8 meters. And if I double that number, assuming that it's going to go up and come back down, then that would be just short of my goal distance. Okay, so if I shoot it at 45 degrees and it goes straight up and comes, back down, we're still going to be about, 8 meters short. So back to the drawing board again.